Hey there, it's Dina from IDon'tGetItTutoring.com. In this video, I will be going over geometric sequences. Let's get started. Geometric sequences are very similar to arithmetic sequences. And if you don't know what an arithmetic sequence is, go ahead and watch our video on our YouTube channel or on our website. It's super informative and tells you everything you need to know about arithmetic sequences. So, geometric and arithmetic, very similar, but not quite. There's a difference between geometric and arithmetic. They are not equal. Geometric is when you are multiplying by the same amount each time. There is a common rate. With arithmetic, if you remember from our video, you are adding the same amount each time. There is a common increase, a common amount. So let's say we had a geometric sequence of, let's say we had a sequence and we're trying to get the third term. Our first term is 3, and our common difference is 2. Now, if this were a geometric sequence, let's start with arithmetic first. If this was arithmetic, obviously our first term is 3, and since we're adding the same amount, we would add by 2. So 3 plus 2 is 5, and 5 plus 2 is 7, and boom. There's arithmetic. Our third term in this series or this sequence would be 7. But if it was geometric, you would do something a little different. Actually, I'm going to move that under arithmetic. No, so we don't get confused. Okay. All right. Same thing applies to this side now. We want to find the third term. We know that our first term is 3, but this time, instead of adding by 2 each time, it says we multiply by the same amount. So we are multiplying by 2 each time. 3 times 2 is 6, and 6 times 2 is 12. So if it was a geometric series, our third term would be 12. 12 and 7 are different. So you always have to be careful in a problem to see if you're working with an arithmetic or a geometric sequence. You need to know the importance of multiplying or adding. You need to know the difference. The difference is so important because it can give you 2 completely different numbers. Now, more on geometric sequences. Now that we know basically the super basics of it, let's just put down a definition. A geometric sequence you multiply, like I said, by the same amount each time. Or you increase by the same rate. Now, amount and rate are different. When you multiply by an amount, it's like you're multiplying by 5 each time. That's fine. But if you're increasing by the same rate, it's basically like percent growth and percent decay. It's not like you're increasing the rate each time, but rather you're increasing by the same rate. So you're multiplying, for example, by 1.04. Also, if you don't know what percent increase and what percent decrease are, check out our YouTube channel and our website for more on that. Once again, super informative video, tells you everything you need to know about that. So over here we have a percent increase of 4%. So if you're increasing by 4% each time, you're not multiplying by 4. No, you are multiplying by 1.04. So you're increasing by this rate, or this, you're multiplying by this amount. There is a difference in the vocabulary. You need to know this. It's very important. So now, it's easy to find, let's say, the third or fifth term in a geometric sequence because you're just multiplying something 3 times or 5 times. And that could be done in under a minute. Very easy. But let's say you wanted to find the millionth term. It's not like you're going to sit there multiplying all these numbers, a million numbers. That's going to take hours, days. I don't think you or your calculator could handle that. So, super easy way to find out any term, the value of any term in a geometric series can be done with this formula right here. Allow me one moment to pull it up. Okay, so the formula for a geometric series also, series and sequence are interchangeable. You will hear me say sequence and series, but just know that I mean the same thing. And that is, I will write in both notations, a subscript n. For any term, you multiply the first term by your rate to the power of the number you're trying to find, minus 1. In the different notation, it would be also written as this. Oops. Okay, so what this means is to find, let's plug in a number. To find the 100th term, you take your first term and you multiply it by that common rate. In arithmetic sequence, we had the common difference, but usually in geometric series, you're going to see it as the common rate. Sorry. Yeah, I know it's confusing, a lot of variables, a lot of letters, but if you know the logistics behind it, then you're not going to have much of a problem with what the letter is. You'll know the formula and how it works, and you'll be able to solve it from there. And you multiply it by a certain rate, and that rate is raised to the power of 100 minus 1. Because, as I had illustrated in the arithmetic series video, let's say we have 5 numbers here. Okay, so as you can see here, we're multiplying by 2 each time. We're doubling. Now, we found the fifth term, right? But we only multiplied by 2 4 times. So that is why we're doing 100 minus 1. Because let's say this was 5. Five minus 1 is 4. We're multiplying 4 times, not 5. So even if it was like the millionth term that we're trying to find, we're only multiplying by that rate 999,999 times, not a million. Or even 100. We're multiplying by 299 times, not 100. Okay? So we're multiplying by 2 4 times, and it can also be written as 2 to the power of 4, because 2 times 2 times 2 times 2 is equal to that. And if you know the exponent properties, 2 to the first, you add those exponents. 1 plus 1 plus 1 plus 1 is 4, because 2 to 1 plus 1 plus 1 plus 1 is 4. 2 to the 4. Okay? So in this video, I covered the difference between geometric and arithmetic sequences, what a geometric sequence is, and how to find the nth term of a geometric sequence. Thank you so much for watching. I hope this video was helpful, and I wish you luck in your studies. Thank you. Bye.